Hello and welcome to NISA School of Mastery. Alright, so today we'll be learning chemistry and we are treating one of the very foundational topics under chemistry. Is that okay? So I'll be reading from the material in front of you. Although that you pay attention even as we study together. Alright, so starting from the first topic we have there, matter. Now let's read. Matter is any substance that has mass and takes up space. All right, I'm sure that's foundation, that's fundamental. Everybody knows that. That's basic. Okay, so let's read on. Simply put, matter is every physical thing that we see around us, and that's it. That's it. That's the main point you need to know there. Matter is every physical thing that you see around you. Everything, your shoe, your bag, your clothes, your phone, everything around you. Those are what we call matter. Once it can occupy space, what does it mean to occupy space? It means that once a particular object is there, nothing else can take up that space. For example, where you are seated right now, or where you are lying down, or anyhow, nothing else can take up, can stay there again. You have occupied that particular space. So that's what it is. So matter is everything that you see around you, okay? All right, so let's move to the next one, atom. All right, atom. Atom is the smallest unit of a chemical element that retains the properties of that element. It is the basic building block of matter. Yeah. So I told you matter is everything around you. So the basic building block, meaning the foundation of every matter. That means what came together to form everything you see around you. The smallest of them is an atom. Is that okay? It's an atom. The smallest particle that came together to form every substance you see around you now. It's an atom. Like I said, that it is the basic building block of matter. Just like the way you can see a building now, a building, and then a building was formed by different layers of blocks, right? Put together. Yeah, that's how it is. Different layers of blocks. So that's how atom is to every substance. So every substance you see around you is formed from different what? Atoms laid together, put together, coming together to form all the substances you see around you. So atom is the smallest and the foundational, the basic unit of every substance. All right, so that's why it is quite important for us to study atom. Are you getting it now? So that's why the first topic we need to understand under chemistry is what the study of the study of atom. You need to understand atom. So let's continue reading. So fundamental particles of an atom. An atom is made of three fundamental particles: one, protons; two, neutrons; and three, electrons. They are referred to as subatomic particles. Yeah. So we told you an atom is the basic building block of every substance. So now we are studying atom now. We are focusing now on atom. Is that okay? We are focusing on atom. So and we can understand that atom is made up of three particles. Not more than three, not less than three. Basically three, the proton, the neutrons, and the electrons. Those are the three particles that you will always find when you mention an atom, and it is referred to as what? Subatomic particles. So as we continue in these classes, when I want to refer to those three, any of those three, I will mention them as what? As subatomic particles. All right. So let's continue. Properties of subatomic particles. So let's look at their properties. Each of those subatomic particles has their own unique property. Is that okay? They have their own unique property. So for the first one, let's consider in terms of charge. Let's look at their property when it comes to what? When it comes to charge. So for proton is positively charged. You can see that. That's +1. It's positively charged. Neutron is neutral, no charge. That's 0. Are you okay? That's 0. And then electron is negatively charged. That's -1. That's the properties in terms of charge. Now let's look at the properties again in terms of their location. Are you following? Their location now. For proton, is in the center of the atom. So your proton is located in the center of the atom. It's called nucleus. All right. in the center is called nucleus. Your neutron in the center of the atom, also both proton and neutron are in the what? In the center of the atom nucleus. And your electron on the surrounding shell. Yeah, your electron is on the surrounding shell. It's not in the center, it's at the surrounding. All right. We call it shell. We call this what? Shell. So proton, nucleus, neutron, nucleus, and electron shell. Good. Now let's look at their relative mass. Let's look at the mass now. The mass, all right. So the mass of proton, the relative mass of proton is 1. All right. The relative mass of neutron is 1. And then the relative mass of electron is 0. All right. Electron is very, very light. It's very, very light. So we take its mass to be what? To be 0 because it's very, very light. So those are the properties of the subatomic particles. They are very important properties that you need to know because you will need them even as you continue in this particular topic. So the diagram you are seeing here is the atomic structure. All right, this is the atomic structure. The green represents electron, the green with the minus in the middle. So that minus represents negatively charged. That's electron. The blue one represents proton with the positive charge. And the red one represents neutron with no charge. It's neutral. So as you can see from the diagram, the proton and the neutron are in the center, right? Can you see that? They're in the center there. Can you see that? Yeah, they're in the center. And while the electron are at the surrounding. We call it shell. That's the atomic structure. Is that okay now? So quickly let's move further in the class. All right. So now let's move to the next let's move to the next subject we'll be considering, and the next topic rather, nucleus and shell. Okay, let's talk about the nucleus and shell for a minute. So what is nucleus? Nucleus is the core, center, that means of core, center of the atom consisting of the proton and the neutron. We've learned that before, right? That the proton and the neutron stays in the middle, right? In the center. All right, this is it here. Yeah, can you see that? In the center of the atom. We call that center, we call this the nucleus. Are you getting that now? This is called the nucleus. So nucleus is the core, center of the atom, consisting of the what? Of the proton and the neutron. Note, nucleus is not the same as neutron. Okay, nucleus is not the same as neutron. Okay, nucleus is a region in the atom that contains the particle neutron. So you know the sound that I can. Sometimes you may want to mix it up, nucleus, neutron. Okay, so nucleus and neutron are the same thing. So nucleus is a place where the neutron stays, not just the neutron, even the proton. So nucleus is a region where the neutron stays. So they are not the same thing. Nucleus and neutron are not the same. Is that okay? So let's move to the next point there. Shell is an orbit around the nucleus where the electrons revolve. That's the shell. The orbit, that round orbit. Okay, that's what we call shell around the nucleus. Yeah, that's where the electrons revolve. They don't stay in the nucleus like proton and neutron. They stay around the shell. So in summary, proton and neutron are in the nucleus, while electrons are on the shell. Is that okay now? I'm sure you understand that. So let's move to the next topic there. Next topic, we have atomic number. Now, let's talk about atomic number for a minute. All right. Atomic number is the numerical identification number of an atom. So what does that mean? The numerical and identification number. All right. In the particular, it is the atom's number. So let me explain that. For example, if you have written a government exam before a general exam, or you have your numbers, right? You have your number in the exam. If you have written, each of you have number 1, number 2. You have your number in the exam, such that I can come to the exam and I say number 10, stand up, and without mentioning your name, you will know that I'm talking about you. Okay, I've called your name, all right, by your first name, but I can just also mention your number. So that means your number is your identification number. Are you guys understand? That number can identify you. Only you have that number. It is yours. Are you getting that now? So if I say number 15, and that person will stand up even without mentioning the name. So that's the same thing atomic number is to an atom. It is the identification number of an atom. So that means I can just say atom number 10, and we will know atom number 10. That, oh, you're talking about neon. All right, that's neon. Without even mentioning the name, I can know that, oh, that's the one you're talking about. I can say atomic number 1, and I'll know, oh, you're talking about hydrogen without even mentioning the name. All right, it is the atom's number. That's how we identify the atom. Is that okay? Good. So note, let's read. Atomic number is determined by the number of protons in the particular atom. What does that mean? All right, let me explain. So, for example, the example I gave earlier, that if you're in the exam or you have your number, right? So that number, how were you given? What determined how you were given? So most times it is alphabetical order. Am I correct? Alphabetical order. So the person with the A, surname of A, takes number 1, like that, gets to B, gets to C, to D. So the ones with the surname of Z take the latter numbers. So in your exam notes, we use alphabetical order. But for an atom, to know the number, to give them numbers, which is the atomic numbers, we don't use alphabetical order. No. For example, hydrogen is number 1, and it starts with H. Calcium is number 20, and it starts with C. So we don't use alphabetical order. So to know the atom's number, what we use is the number of protons. That's what's there. To determine the number of an atom, what we use is the number of protons. So if an atom has 5 protons, that means that particular atom will be number 5. So once we check number of protons in the particular atom, we use that number of protons to determine the atomic number. So that's how we determine the atomic number. We use the number of what? Of proton. So that's Z. Look at that. Z is equal to NP. NP means number of proton. So Z means atomic number. That's the symbol of atomic number. Z. So Z is equal to number of what? Of proton. Is that okay? All right. The next one. Mass number is the degree of heaviness of an atom. So mass number. We're talking about mass number now. We are done with atomic number. What is mass number? Is the degree of what? Heaviness. Meaning, how heavy is the atom? It's as simple as that. How heavy is the atom? All right. So for example, if you have a school bag, how heavy is your school bag? All right. Not the number now. I'm not saying the identification number now. I want to know how heavy it is. So to know how heavy is your school bag, I will have to add up the books in the bag. Maybe you have 3 textbooks and you have some notebooks and some pen. I will have to add up everything you put inside the bag to know the mass of the bag. Is that right? So once I add everything in the bag, that will be the mass of the bag. So same for an atom. If you want to know the mass of an atom, you have to add everything in the atom together. You have to add everything in the atom. So how many particles in an atom? Just 3. You've learned that before. There are just 3 particles in an atom. Proton, neutron, and what? Electron. So if I want to know the mass of an atom, what I need to do is to add up all the mass of the particles in that atom. The mass of the proton, mass of the neutron, and mass of the electron. All right, so let's read. Mass number is the degree of heaviness of an atom. It is the sum of the protons and neutrons in an atom. Okay? It is the sum of the protons and neutrons in an atom. Electron is excluded. We don't add electron. Normally you should add everything, but we don't add electron because the relative mass of electron is 0. So you remember in the first page that we learned that the relative mass of what? Of an electron is what? 0. It is very light. Under the properties, the price of proton is +1. That of electron, the mass of proton rather is 1. The mass of neutron is 1, but the relative mass of electron is 0 because it is very light. So because it's very light, we don't used to add it. Is that okay? We don't add it. Imagine you have a school bag filled with textbooks and a cotton wool. You now put a cotton wool there. So the cotton wool, will it really affect the mass of the bag? Not really, although it is there, but it won't really affect the mass because it is very light. And that's basically how it is. So we don't really add the mass of electron. It is very, very light. So all we do to know the mass of an atom, we add the mass of the proton and the what? And the neutron. Is that okay now? So that's what it says. A is equal to NP. A means mass number in chemistry. Is equal to number of proton plus number of neutron. Okay. All right. So that's all for that. So additional information on atoms. Let me just round off with that. So I won't really dwell on that. We'll meet more of that in our next classes. So number one, the number of electrons in an atom is always equal to the number of protons. Very important information. The number of electrons is always equal to the number of protons. So once an electron has 5 protons, it will have 5 electrons. It will have 5 electrons. If it has 10 protons, it will have 10 electrons. So you don't need to bother about knowing the number of electrons. Just go and check the number of protons. Once you know the number of protons, you know the number of electrons. They're always the same. They're always the same. All right. Number two. Therefore, an atom is electrically neutral because it always has equal number of protons and electrons. Okay? It's electrically neutral. What does that mean? Their numbers are always equal. Are you getting that? But their charges are opposite. They have opposite charges. So, for example, if a particular atom has 5 protons, that's what? That's plus 5, right? All right. So, if you have how many electrons? It also have 5 electrons, right? That's minus. No, electron is negative charge. That's minus 5. That is what? 0. Do you see that? So, at the end of the day, the atom is neutral, 0 charge.